Video we are going to look at a speed time graph and use it to discuss acceleration. This is a 6-mark question, so there is a lot that you can write. Pause the video now and try this question. So there is a lot we can write in this question. It tells us to compare Helen and Finn's acceleration over the whole run. So we've got to discuss all of this graph. In general, it's always good to start by breaking it down into sections. So if we look at the different sections in this graph, we've got Finn initially, we've got Helen initially. They then change, so Helen obviously changes what she's doing, and we can also see Finn changes what he's doing. So if you don't know what to do, breaking it down like this is a good start, and we can probably say at least 4 different things, and then we can talk about the whole run, so their whole journey. So let's look at the yellow section. So we could say let's say for Finn, let's say in the first 900 seconds, his acceleration is, and then we need to obviously know what acceleration is. So acceleration is change in velocity over time. So here, what's the change in velocity? It's going to be 3 minus 0 over time, which is 900 seconds. So I'm just going to get my calculator to work that one out. So 3 divided by 900 is 0.003 meters per second squared. What about in the second half of the race, in the second 900 seconds, so this orange section here, what is his acceleration? So it's going to be 0 minus 3, final velocity minus initial velocity, over 900. So it's going to be minus 0.003 meters per second squared. So this means he is slowing down or decelerating. What about Helen? Well, Helen, in the first 900 seconds, she is accelerating 2.4 minus 0 over 900, which equals 0.027 meters per second squared, which is less than Finn. And I'm going to make sure I compare, because it does say use the graphs to compare. So I'm going to make sure I've got that comparison in. And then we could say in the second half, her acceleration is 0. Why is it 0? Because we are a constant velocity. You can see it's a constant 2.4 meters per second squared. So this obviously is less than Finn's again, or we could say it's different to Finn's. Finn is slowing down and she is moving at a constant velocity, so maybe actually that's better. Finn is slowing down, she moves at a constant velocity. Is there anything else that we can say? I mean, it asks for only acceleration, so we don't need to work out distance. Distance would be the area under the graph. So for example, if we wanted to work out the distance that Finn travels, we could work out the area under the graph, which would be this bit here, so the area of the triangle, but it doesn't ask us to do that. We could also work out something like the average velocity, where we could do the total distance divided by the total time. But again, we're not asked to do that. So I think this here will actually give us 6 marks. The calculations, if you write them out fully, is going to be enough to give you 6 marks.